Hello wonderful person, this is Anton, and today we're going to be discussing some of the new updates and some of the new discoveries coming from our red neighbor, Mars. Because as always, we have some major scientific findings coming from this beautiful red planet. But to start, let's take a look at something that's not particularly scientific or particularly exciting, but something that does look kinda cool. A donut rock, recently discovered by the Perseverance rover, with the one big question being, what exactly created the hole? Now, unusual rocks are very common on Mars, and you can actually find some videos in the description talking about previous discoveries, but in this case, the shape in the middle is very likely a result of long-term erosion that most likely broke the inner pieces, which you can now see lying around surrounding the larger structure, with the rock itself almost certainly being a relatively old meteorite. Once again, very common on the surface. Here's what it looks like with the slightly different coloration, revealing a slightly different composition. But I think this image is a little bit more intriguing. This shows us Mars like we've never seen it before. This is Mars in the ultraviolet. And it's actually two different pictures taken months apart, actually showing us the seasonal changes on the planet. These were taken by the Mars Atmosphere and Volatile Evolution probe, also known as MAVEN, that's orbiting the planet observing various atmospheric processes. And what it actually allows us to see in the ultraviolet is the interaction of different gases in the thin Martian atmosphere, including, and this is actually really cool, Martian aurora, only visible in the UV light. But unlike aurora on Earth, the ones on Mars are produced in an entirely different way, with the process being a little bit more complex. The video in the description describes it in more detail. But the purple stuff that you see here, it's actually ozone, with various other hazes, or various types of gases, appearing in white or blue. And so this first image from July of 2022 shows us the southern hemisphere when it was summertime. Not much going on here. But then by early 2023, we suddenly observe a lot of seasonal changes that seem to produce a lot of white clouds, especially in the northern hemisphere. But more excitingly, a huge buildup of ozone. Nobody is certain why yet, but that's what seems to happen on the planet every time there is a major seasonal change. We'll hopefully get to learn more about this in some of the future studies. On top of this, we also got to learn a little bit more about the Martian crust and a lot of other surface processes. Turns out that the crust here is somewhat different from planet Earth. All of this data was collected by the InSight probe that accidentally heard a relatively powerful Marsquake, allowing it to reveal a lot of data from inside the planet. And so Mars, which obviously has just one thick plate compared to Earth that has plate tectonics, seems to have a much thicker crust. On average, it seems to be anywhere between 42 and 56 kilometers, and that's basically almost double of Earth, where it's usually anywhere from 21 to 27 kilometers. And even thicker than the crust on the Moon, where it's believed to be about 34 to 43 kilometers in thickness. But on Mars, it also seems to differ quite a lot depending on where you look. The thinnest crust is around what's known as Isidis Impact Basin, and here it's only about 10 kilometers. This area was previously explored by the Beagle rover back in 2003. Here, the explanation is obviously that it's a crater, with the impact very likely creating a much thinner crust. But the thickest region is right here. This is the region known as Tharsis, and here it's over 90 kilometers thick, which is way more than anything on Earth. And more intriguingly, and more importantly, there's a huge difference between the north and the south. This is actually something that we've known for a very long time, but as you can see from this image, there's a definite dichotomy in terms of the total thickness of crust. It's as if this planet was created from two separate pieces. Now previously this was believed to be part of some kind of a major collision a long time ago, but even today it's not entirely clear why this region looks different. This was also very likely an ancient ocean, but once again, still a little bit mysterious. Although I'm sure we'll learn more about this as we get more data from various rovers and from various orbiters. Here's actually another really intriguing picture that was recently released by one of the orbiters, in essence showing us ancient lava flows and ancient lava tubes that were most likely created by some kind of a collapsed terrain billions of years ago. Here this is approximately 70 kilometers across. We also have some other mysterious anomalies recently detected by several different rovers and several orbiters. In this case, it's in regards to what the scientists now refer to as magnetic pockets. Turns out that both rovers and orbiters seem to get different results when they measure magnetosphere or magnetic field. The Chinese Zhurong rover, for some reason, was not detecting a very strong magnetosphere, even though several Martian orbiters were seeing something very strong in a location not so far away. Intriguingly, the InSight probe, that was active up until relatively recently, has also detected magnetic field that was much stronger than originally believed, but the orbital measurements, especially in the region nearby, were once again different. With the implication being that Mars seems to have these unusual pockets of magnetosphere, with other regions being demagnetized over time, but some regions staying magnetic even today. The actual field here is actually kind of weak, something like 1.5 microtesla at its maximum, or about 30 times lower than the average field on Earth, but that was at the maximum. The average field was about 10 times lower than that, or about 1/300th of what we have on planet Earth. But this does seem to differ quite a lot, with certain locations being way more magnetized than others. And so if this is what the map of Mars kind of looks like, here's roughly what the magnetic fields seem to be like. Some locations are very magnetized, some are completely demagnetized. But exactly why this is so is obviously not currently known. Here's another beautiful video of Martian dunes inside one of the Martian craters that was taken by one of the orbiters. And by itself this is a beautiful image showing us the planet like we've never really seen it before. Now this crater is actually really exciting. It's known as Matara crater, approximately 50 kilometers across. And just like so many other unusual Martian craters, it seems to contain a huge amount of sand dunes right in the middle of the structure. I think this one here is the most famous, the Victoria crater. The picture that was also taken by the Mars Reconnaissance Orbiter. The scientists would really love to explore these dunes, but we don't really have a very good record with Martian rovers in sand. For example, the Martian Spirit rover eventually got stuck in the sand in 2010, and that's how its mission was ended. But these regions are really exciting for many reasons. Because, for one, there seem to be actually signs of ancient water flowing across the dunes. As a matter of fact, some of these locations seem to resemble various gullies located in places like Antarctica, which are very often caused by melting glaciers. And so various scientific teams would really love to find out if it actually is from flowing water, or if it's something entirely different. And if these were produced by water, it might have happened approximately 600,000 years ago, and could have been a result of a major climatic change on the planet. One of the studies recently explored this, discovering that it's definitely possible if the planet itself dramatically changed its tilt, closer to about 35 degrees. And if the planet did change its tilt dramatically, it would change the overall density of atmosphere, it would also change the temperature, and would even cause certain locations to heat up above the freezing point of water. At least certain types of salty water, assuming that there were some deposits somewhere. And this would be of course very similar to what happens on Earth, with the concept of Milankovitch cycles, but for Earth, these changes are not as dramatic because we have something that stabilizes everything. Our moon. It prevents the Earth from wobbling too much, and it prevents the Milankovitch cycles from getting out of control. But on Mars, it could actually flip quite a lot, thus changing the atmospheric conditions and the climate quite dramatically once in a while. Something that was recently simulated, and something the scientists believe might have happened possibly a few 100,000 years ago. And there's actually even more proof of this coming from a slightly different study. This one studied the orientation of dunes. And what the scientists did here is pretty clever. They looked at the orientation of dunes and the overall age of the dunes in various locations on Mars. Dunes are obviously formed by the action of the wind, with the wind in this case usually having a generally similar direction. But turns out that something happened on Mars approximately 400,000 years ago, which dramatically shifted the direction of the wind. The orientation of dunes seems to have changed by approximately 70 degrees, which to the scientists behind this paper implies a dramatic change in climate. Once again, very likely due to the axial tilt of Mars. Seasonal change cannot explain this entirely. Now once again, this is very similar to what we expect from Milankovitch cycles, but in this case they're just way more extreme than anything on Earth. And that's of course because Martian moons are just way smaller, and thus cannot really affect Mars from flipping completely or from having a lot of axial tilt. But exactly how Milankovitch cycles would work on Mars has never really been studied in detail. Nevertheless, the implication here is that once in a while, the Martian climate changes dramatically and can potentially even become just a little bit more Earth-like, very likely even producing liquid water and very likely dramatically changing the overall density of the atmosphere. How or why, still unknown. But we'll be definitely discussing some of this once someone figures this out. And then, last but not least, is the discovery coming from the Perseverance in regards to the composition of various rocks that it already analyzed so far. This was the famous one, the Mahas rock. And the discovery here is of a lot of different complex organic molecules, something that everyone was very excited to find, but something that currently does not make sense. Mostly because even though the rocks are actually quite close to one another, they do seem to have a very different number, type, and concentration of various organic molecules that were discovered so far. Now we don't really know exactly what molecules they are, but they all seem to have complex carbon chemistry, and many show signs of being created around liquid water. And so the discovery of hydrocarbons on Mars, and specifically ones created around liquid water, is definitely very exciting. It of course suggests that the organic matter here could be all over the place. But you might want to check out one of the videos I made about Antarctica that kind of suggests discovering actual life here would be extremely challenging. Current instruments are just not good enough to find direct signs of life. Nevertheless, we might hear more about this in the next few months. I was actually going to talk about the Martian helicopter as well, but it deserves its own video that's going to be coming out really soon. In a nutshell though, it finally called back home after 2 months and seems to be still functioning. It did actually have a bit of a silence period because it was difficult to communicate with the rover due to the location where it landed and due to the rugged terrain. Nevertheless, still works, still flies. But we'll talk about the helicopter and additional discoveries from the mission in the video very soon. On that note, check out some of the previous videos in the description, check out all of the studies in the description. Thank you for watching, subscribe, share this with someone who has learned about space and sciences, come back tomorrow to learn something else, and maybe support this channel on Patreon by joining channel membership or by buying the wonderful person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.